Hi guys, and welcome to my YouTube channel. In this video, we'll be wrapping up day 1 of this year USEMO. So we're finally discussing the most difficult question of day 1 paper. Basically, this question is a geometry question. In the previous 2 videos, we finished the problem 1, problem 2, which were combinatorics and a number theory question. This video will be wrapping up with a geometry question. So I hope you guys excited for this question. So what are we waiting for? Let's go. Alright, our third problem and last problem for day 1 is the following geometry problem. As you can see, we've got a simple triangle ABC, an incenter I, and they're defining 2 points P and Q on the circumcircle, such that API, angle API and angle AQI are both 45. Then we're taking this line PQ, intersecting it with BC at a point S, and they're defining H to be the projection from A to BC. We need to show these 2 angles are equal. Okay, let's start with like a diagram. So basically, the question is kind of simple in like regarding the points. We don't have that many points, so let's immediately start by just drawing a circle. And triangle. Let's say I is here. We need to choose 2 points such that, of course, like we need to project this as well. So let's do this projection. And we need to define the 2 points such that, like 1 point here, let me see, and another point there. Of course, like we know that this angle is going to be 45. So yeah, maybe something like this. And let's see the other one. Yeah, something like this. Okay. And now, like, what we need to do is we need to like intersect these 2. Okay, so let's shift our diagram to the left. And this is exactly why I always tell you to draw a draft, like draw like a quick diagram on your draft to make sure that you don't draw like to spend much time and then like you get something like this outside the page. So no, make sure that you always draw a small diagram and then draw the precise diagram. Anyway, right now just going to intersect these 2, some point here. Okay, this is our point S, and this is, let's name the triangle A, B, C, P, Q, and this is I, and this is H, and we're asked to show that angle AHI, so basically this angle here, this one, is equal to angle ISH. ISH, so that means we need to draw this. So yeah, it's equal to this angle here. Okay, and like don't forget that the main definition is that these 2 angles are 45. And 45. And this is, of course, like the altitude. Alright, let's get started. Let's have a look at our question now. As you can see, like all of these points are cool, like I, H, B, C are the original like triangle. The only problem is this definition for these 2 weird points. These are not like really familiar points that like we just have 2 points on the circumcircle such that we know this angle AQI is 45, same thing as this API, and then we just like intersect these 2 to get S, intersect PQ with BC. Alright, so as you can see, the question is kind of simple in regards that we don't have many points. We just have like actually like two weird points PQ and just like a point S. Okay, what am I referring to here? What do I mean? That actually gives us a nice kind of configuration to try like bashing techniques here. Of course, like this is a geometry question, and as you know, most of the geometry questions they have either like a synthetic, poor geometric, like synthetic approach to solve. Of course, this question as well, or you can go with a bashing technique. Of course, this is not always like nice. It depends on the question, but usually when you have like your diagram, you don't have that many points, and when your points, you find a way to define all the points in a nice way. Of course, that depends on your bashing system. Are you using barycentric coordinates or you're using complex coordinates? Yeah, you need to like to check that as well. And like if you haven't studied like complex bashing or barycentric bashing, then I highly recommend you to do so because it's really important. In fact, like I solved my IMO like question, IMO 2019, like the geometry question, I solved it using barycentric coordinates. So it's really like an important thing that you shouldn't delay. Of course, first of all, make sure to be like strong in synthetic approaches, and then like make sure to learn these as well, these bashing techniques. Okay, so right now what we'll be doing here, we'll be trying to like use a complex bashing technique. So if you really are not familiar with complex bashing, then make sure to study like EGMO chapter 5, sorry, I mean chapter 6, about complex numbers. And hopefully on this channel right now, I have uploaded chapter 1, chapter 2. So once we, like hopefully like pretty soon, we're going to cover that as well, chapter 6. Okay, right now I will assume that you have the basic knowledge of the complex bashing, and we're going to try to find a complex bashing technique here. Okay, so let's approach this question. First of all, like if we want to use here complex bashing technique, complex system, then like usually the standard approach is just to take this as like the circumcircle to be the unit circle, and we have like A, B, and C. They are all on the unit circle. But the problem is, how do we define I? To define I, like to work with I usually, we need to make this definition like A, B, and C. We make them like U square, V square, and like omega square. And then we will have I, the in-center, is just negative UV, negative VW, negative WU. So this is like very standard thing to deal with the in-center. So exactly this is what we'll be doing here. But then, okay, we have the I like as we want. We can find, of course, the H as well. It's very easy. It's just like the projection. We use the projection formula. That is half A plus B plus C minus BC over A. Okay, so we can actually represent A, B, C, I, and H, all of these. But now what do we need? Like our main challenge is P and Q, right? Of course, to find S, if we know P and Q, then we can, like to find S, it's very simple. We just intersect line PQ with line BC. And because these two are chords in the unit circle, then we can just use the formula for that. So now our main challenge is how to deal with P and Q. First of all, we know both of them lie on the unit circle, which is really a nice thing. So now we just need to handle the angle condition. So we have this angle like 45 here and 45 there. How can we really like try to use this in a nice way? Because these two angles are on the unit circle, what you can do actually is do the following like simple thing. If you just extend this, we know that this is 45, right? So that means this thing here is going to be, this arc is basically 90 degrees, right? If you just extend this. So we know exactly what is this point here. Like if you have like point A, if you actually here, like give A coordinate of 1. Let's assume that A is actually 1. So that means the x-axis is like OA, right? OA. then you can assume A is 1. So let's do that. If A was 1, then what exactly is this point here? You use like you're at A and you go 90 degrees, right? So it's basically I or negative I, right? Depending on whether we're going clockwise or anti-clockwise, depending on the y axis. So we choose this is the x axis. This will be the y axis, right? So it depends. Like, are we directing it like this, or we're directing it like this? Anyway, at this point will be either I or negative I. This one here. So let's define this point as Q prime. Let me actually change the color here. So this thing is Q prime, and we can do the exact same thing for pi. If I just extend pi, going to get p prime as well. So again, like one of p prime, q prime, one of them is I, the other is negative I. And that means since we know like p prime, q prime, and we know I as well, then it's very easy to find p and q. What exactly will be our approach? Remember, there is a formula that tells you if 3 points are collinear on the unit circle, on a chord of the unit circle. We already have this is our chord p prime, so we just like put I on it, and we'll just work to find the p and find q. Okay, so that will gives us p and q, and once we find p and q, then we can find s. And of course, once we find s, then our job will be just to make sure these two angles are equal. That means we need to, of course, like our main thing will be, first of all, I'm going to refer to I like with coordinates j. I will not say I because it will confuse you with the complex I, right? The imaginary I. So let's just represent it using j. And our final goal is to do what? Because it's very important to see whether you can actually work the final goal using complex coordinates. Like otherwise, of course, you should not consider the whole approach from the beginning. Okay, so right now, let's see how can we work with angles here. Well, you can just show that the angle ISH, we're going like this. So let me like say J minus S divided by H minus S. This thing like has like this number has, of course, like an angle, right? It represents this angle actually. And we also look at the one representing this angle. Of course, right now, remember, we went like this. So we went clockwise. So we should also here go clockwise. AHI. So that means A minus H divided by J minus H. Okay, these two have the same angle. That means they have the same like arc, right? The same like arc. That gives us the angle for each one of them. So that means if you take these two and divide them by each other, since they have the same arc, then that means you're going to get a real number. So if we can just show that if we divide these two numbers by each other, we're going to get a real number, and then we're done actually. So this is exactly what we'll be doing. Our main plan will be to calculate J minus S divided by H minus S and multiply that, because we're dividing, so we're multiplying by the reciprocal of this. That is J minus H divided by A minus H, and we need to make sure this thing is a real number. Alright, this is like, that means we can actually go for a complex coordinate approach. We can find everything using coordinates. And yeah, now, since like we already know what to do, now we have an algebraic battle, because like this will not be like really simple. We need to make sure like to, right now, of course, we're done with geometry. Our main challenge right now is just to work with the algebraic quantities, like factorize them, and like try to do like all the algebraic tricks and not miss any of them. So let's start to do that. All right, so before we get started, this quantity that we want to show, it's like a real number. If you have a look at it, it contains J minus S. First of all, J minus S is this line. It also contains H minus S, which is this line here. So if you look at it, we know that the coordinates of S will be really ugly. So the complex number that represents S is going not to be like that much cool, because like it depends on P and Q and then intersection formula. So if you can avoid it, then clearly you should do that. To find J minus S, you cannot avoid it because this represents this line. However, for H minus S, this line is actually the same as B minus C. So yes, you can actually escape from it now. So instead of working with H minus S, clearly you should work with B minus C. It's way like easier. So let's replace H minus S with B minus C. So here, working with B minus C. Okay, what about the other one? So here you have J minus H. It's this line here. And we also have A minus H. So if you know like the projection formula, it's actually not that nice because it's half times like A plus B plus C minus BC over A. It's like a little lengthy. So if you can escape from H, also you should do that. So I minus H, you cannot escape from it because this is the line IH. You cannot really escape from it. But the line AH is the altitude actually. And do we have another point like beside H on the altitude that's nice? You can like talk about maybe the orthocenter. It's A plus B plus C. But actually you can even have like a better point, and that is this point here. This point here is like really a nice one because first of all it lies on the circumcircle or the unit circle here, and actually it's like really easy to find. In fact, it's just negative BC over A. So yeah, for sure you should do that. So instead of working with this, let's call this point T, and let's work with T. So instead of writing A minus H, we will write A minus T. Okay, so now our goal is to find this as a real number. Of course, we'll be evaluating everything, but first of all, let's find the coordinates of the main points. So let's get started. So first of all, as we said, we're going to let A be 1, B is going to be U square, C is going to be V square. And why we're doing this? Because we want like I, or J basically, J to be negative UV, negative, simply like minus UV plus U plus V. These are all like well known. As I told you, you need like in order to follow with this video, with this solution, you need to make sure that you studied some like complex coordinates, let's say chapter 6. Okay. So that's for J. Next, okay, we have H. Let's find H. H is half times A plus B plus C, that is here 1 plus U square plus V square minus BC divided by A. So that is U square V square divided by 1. So yeah, that's it. This is H. Okay, remember we put like T. So actually to find T, we already know this formula that if you have two chords that are perpendicular on the unit circle, then you know this thing. You know AT is perpendicular to BC, then you know that A times T plus BC equals 0. That means T is just minus BC divided by A. Minus BC divided by A minus BC. So it's minus U square V square divided by A, that is 1. So this is T. Very nice. Okay, now we're done with the simple points. Let's move on to find P and Q. Again, what's our plan? How do we find P and Q? Remember, to find P, let's say, we're going to use this idea. First of all, P prime and Q prime. One of them is I, the other is a negative I. So let's write that first. We know that P prime, Q prime, one of them is going to be I. Let's like assume that actually it doesn't really matter, but let's assume that P prime is I and Q prime is negative I. Let's assume that. Now we're just going to use the like 3 points collinearity on a chord. So we know that I lies on this chord P prime. So let's just use that. Again, like this formula that we'll be using is the following. If you know like AB and you have some point P here, then what do we know is that P plus AB times the conjugate of B is equal to A plus B. So basically, we'll just be doing this, but A and B will be choosing them to be P and P prime, and this P is going to be the I. So let's just do that, or basically J here. So, okay, first of all, we're going to take J plus A and B, as we said, they are P and P prime, times the conjugate of G is equal to the sum, P plus P prime. Okay, remember P prime is just the I, so let's just replace P prime with I. And then, of course, we just need to find P, so let's just isolate that. So P times I conjugate of J minus 1 is equal to I minus J. So that just means that P is equal to I minus J divided by I times the conjugate of J minus 1. Very nice. Okay, now we just need to put J, substitute J. So P is equal to I. Remember, J is this thing here. So the negative with the negative, it cancel, become the plus. So I plus UV plus U plus V divided by I times the conjugate of these. Sorry, first of all, it becomes negative and here negative. So let's just put here a negative outside. And now, can just deal with the positive. So now, the conjugate of UV plus U plus V plus 1. Okay, we should not keep this like this. So we should just multiply by UV, both numerator and denominator. So it's going to become minus UV times I plus UV plus U plus V divided by, this thing will become I times, so if you multiply by UV, it's going to become 1 plus U plus V plus UV. Nice. So this is basically P. Okay, so this is our P. Okay, let's just see it here. It's very important to keep organized so that if you mess up, we can just always return to our previous step easily, not to screw up everything and we don't know what's exactly happened. We can catch our mistake quickly. Okay, so we found P. Now we can do the same thing to find Q. In fact, we can do use symmetry here. Symmetry is a powerful tool. What's the difference between P and Q? The only difference actually, Q is also the intersection of this Q prime I, just like this one is P prime I with a circle. So the only thing that changed actually is P prime and Q prime. So here we had I, now we have negative I. So we can just actually write here Q is equal to, exactly everything is the same. We just need to swap I with negative I here and here. So it's going again to be minus UV minus I plus UV plus U plus V divided by I times 1 plus U plus V plus UV. Sorry, this one is minus. Okay, so now we found Q as well. Very nice. Now we just need to find S, right? Okay, now we just need to find S. To find S, S is the intersection of PQ with BC. And these two are chords of the unit circle. So we can just use now the formula, the famous formula that intersect two chords. So I will just remind you of that formula. If you know, you have two chords, AB and CD for unit circle, then their intersection is just the following. It's going to be AB times C plus D minus CD times A plus B divided by AB minus CD. That's it. This is the intersection of them. So now we can just apply this to find S. So what we really need to find, of course, like our points are B and C, and P and Q. So P and Q are the ugly ones. So what you really need to deal with here, two things. Let's say we're working with C plus D and CD. These are our points. As you can see, you need to evaluate the product CD, and you need to evaluate the sum C plus D. Then here again it's the product. So instead of immediately putting everything there and have a very ugly thing, let's do a step by step. First of all, let's find P times Q, and then let's find P plus Q. Hopefully this will become like it will be more organized and like less likely to do like maybe a calculation mistake or some mess up, and it will make again our life much easier to catch like the mistake if we like did some mistake. So let's first of all find P times Q. So P times Q, what is that? Okay, if you look at these two, first of all, the minus with the minus is going to become plus UV square, U square V square. Next, this thing times this thing, they are conjugates, right? If you look at them, like this thing is plus I, this thing is minus I. That means that it's going to be this thing squared minus I squared. Well, guess what? What's I squared? I squared is -1, so it's going to be +1. So it's just going to be UV plus U plus V squared plus 1. Yeah, that's it. Nice. What about the denominator? Okay, so if you look at these two, they're also the same thing conjugate. So it's going to be U square V square minus this thing squared. Again, I squared is -1, so it's going to become plus. So it's U square V square plus U plus V plus 1 squared. So it's just this thing square plus U plus V plus 1 squared. Okay, very nice. This thing is PQ. Now we need to evaluate P plus Q. So let's find that as well. Okay, we need to add them. First of all, you can take the negative outside common factor, UV as a common factor. Yeah, and then you need to do some like to basically multiply. So let's first of all take minus UV as a common factor. And now we need to add these two fractions. This one here and this one there. Okay, when you add them, you're going eventually to need to multiply this thing by that and multiply that by that. And of course, the denominator is going to be what? The denominator is just going to be the product of these two. So that's basically we already evaluated it. It's just the same as this number. Okay, so we can take this as common factor as well. So it's going to be okay. Now we just like need to work with the numerator. As we said, it's going to be the product of these two. So let's just zoom out and try to multiply these. So first of all, we have I plus U plus V, I plus UV plus U plus V multiplied by that thing. So it's just going to be, let me write it, minus I okay, that's the first part. Second one, it's plus minus I plus UV plus U plus V times I one plus U plus V plus UV. Yeah, that's it. Okay, now we just need to try to simplify this because it's way too ugly. So let's have a look how we can simplify it. Okay, so to handle this thing here, we're going to expand, right? Well, actually, if you just go expand, of course you can do that. But remember, like when you're doing like complex bashing, these types of questions, you should always look for smart tricks if possible. Anything that will make you avoid these like ugly calculations. So let's try. Do we have some trick here? If you look at this expression and this expression, look at these. What's like the kind of the difference between them? You can easily see that the only difference is the I, right? They are literally the same. Here we have I, here negative I, here negative I, here I. So like this actually is a very important note, because it will help you simplify this easily. How exactly? Let's see. So basically, if you imagine this here, imagine this as like kind of a real number. These as real numbers like u, v, and 1. Of course, they are not, but imagine that they are. Then you're noticing that only everything that has I is becoming like minus, right? So it's like when you're adding like two numbers. Let's say z is something like a plus bi, and you're adding the conjugate. It's a minus bi, right? When you add them, what do you get? When you add these, you get 2a, right? 2 times like basically the real, right? The real coordinate of this. So exactly, this is exactly what we're doing here. Like everything that has I will cancel, and we'll only have 2 times this number, the thing that doesn't have I in it. So this will of course save us tons of like calculations. So you immediately just write 2 times. This thing is just going to be here 2 times what? How do we get rid of I here? What terms get rid of I? If you multiply this by this, so that means 2 times uv times uv plus u plus v, and these two, the I square will become -1, and negative is positive, so it's going to be plus just 1 plus u plus v. So yeah, all of this is just going to simplify to this. As you can see, this is a very nice trick that helped us save tons of time and effort. So we can just right now write what's p plus q. We'll replace that with this thing here. So that just means that p plus q is equal to minus 2 uv times uv plus u plus v plus u plus v plus 1 divided by uv squared plus u plus v plus 1 squared. Alright, so this thing is p plus q, and this thing is pq. Let's copy paste that so that they are next to each other. Because now we will use them to find, remember, s, the coordinates of s. Because now in the intersection formula we found like both the sum and the product, these. So now we can just plug in, and remember that a and b are like the b and c in our question, and b and c were just like the u and v, the u square and v square, right? So yeah, that's exactly what we'll be plugging right now. So let's go ahead and do that. So first of all, let's multiply a times b. That is like u square v square. So s is going to be first of all u square v square times the sum. The sum p plus q is this thing here. So first of all, this will become minus 2, and instead of squares, let's make them cubes. And now we have this thing. Let me zoom out. Okay, uv times okay, or was it? Yeah, uv plus u plus v plus u plus v plus 1. Okay, divided by u square v square. Let's just write it. Okay, nice. This thing is the first part. Now we need to continue intersectional formula. We need to subtract. And now we need to apply those PQ. So we need to subtract minus this thing here. So let's say minus. Okay, we're going to apply these and multiply them by the sum of b plus c, that is u square plus v square. So let's write u plus v, u square plus v square times, it's just going to be uv, u square v square times uv plus u plus v squared plus 1 divided by u square v square plus u plus v plus 1 squared. Okay, so that's everything in the numerator. Now we have the denominator as well, which is like ab minus cd, that is basically u square v square minus the product. So this thing is the numerator, and we also have the denominator. The denominator is what? It's u square v square minus pq, that is u square v square uv plus u plus v squared plus 1 divided by this thing here. Okay, so this is basically S. Now it's time to cancel stuff. Let's see what we can cancel. Okay, first of all, the numerator and denominator, both we can take u square v square as common factor. So let's, okay, what I prefer here, I'm just going to copy this and we'll cancel on the new one, so that if we make a mistake we still have the original one. So first of all, you have here u square v square, u square v square, u square v square, u square v square. So we can just delete this thing, delete this, delete this, and delete these. Okay, this is step 1. Step 2, you have this thing here, this thing here, this thing here. So now we just like need to put it here actually. So we'll replace this one with that. Okay, nice. Now we can just delete these. Trust me, it's very satisfying when you delete these ugly terms. Okay. So now we have much simpler stuff. Okay, let's just put the minus here so that we don't miss it. Okay, nice. In fact, let's just get rid of the minus here and make this plus and swap these. Okay. Alright, can we simplify anything anymore? I don't think so. Yeah, that's it. So now let's just try to calculate the denominator, as it seems much simpler than the numerator. So let's just do that. I'm going to write this thing is equal to the fraction again. Let's find the denominator. In fact, I prefer like to do it here and then just plug it there. So what we'll be doing is like actually you can here, as you can see, squares. You can use the difference between two squares, right? It's kind of nice. So if we take this and this, their difference is going to cancel the u plus v, right? So yeah, I think this is a nice idea. So if you do that, you pair this with this, you're going to get their difference is going to be uv minus 1. Their sum is going to be uv plus 2 times 2u plus 2v plus 1. And then you have plus 1 minus uv. Oh, that's nice. 1 plus minus uv squared is going to take uv minus 1 as common factor. So in fact, it's like this. uv plus 1. Very nice. So we can take uv minus 1 as a common factor. So let's just do that. We take this as a common factor here. we're going to get this minus this. Okay, these will cancel the uv plus 1. Very nice. So you're just going to have 2 times u plus okay, this is very nice. See, you just need to make sure you're doing everything in a smart way, step by step, and try always to you should really be good with factorization and dealing with these algebraic quantities when you're doing some bashing problem. Okay, so now the denominator is just this. Very nice. Now let's look at the numerator. As you can see, the denominator is just uv minus 1 times u plus v. Hopefully the numerator should not be that ugly. Hopefully, like, we can also factorize it and get rid of these, maybe u plus v and uv minus 1. In fact, actually, there is like one thing you can do. You can actually check whether the numerator can be factorized or not, or at least you can check whether it can have u plus v as a factor and uv minus 1 as a factor. Again, you should be familiar with the polynomials here. So if you want to like have u plus v as a factor in the numerator, then if you have u plus v as 0, the numerator will be 0. So let's see, is that correct? So assuming u plus v is 0, this thing is going to be 0, this thing is going to be 0, this thing is going to be 0. So the numerator will be just, let's see, 2 uv. First of all, let's do this. This thing has become this thing square plus 1 times 2 uv. And what about this? This has become now u plus v squared times uv, this thing square plus 1. As you can see, this thing, you can take it as a common factor. And if you take this as a common factor, you're going to have u squared plus v squared plus 2 uv, which is u plus v all squared. So this thing is going to be u plus v all squared times something. So this thing again is 0. So yeah, that's good news. That means indeed the numerator has u plus v as a common factor. So indeed these will cancel actually. Very nice. In fact, what you can do here, yeah, you know what, I think if you keep this, it's going to help us, because as we said, this thing is just u plus v all squared times uv squared plus 1. Okay, now we can immediately take u plus v as a common factor. And because we know already that it's going to have u plus v as a common factor, we can immediately now factorize this. So let's take everything that has u plus v immediately. So what exactly is that? First of all, here you have u plus v. What are you going to have from this u plus v? You're just going to have uv times it times another 2 uv. So 2 uv squared. Yeah, that's it. What about the other u plus v? It's just going to have plus 2 uv. Nice. What about this u plus v? It's going to be squared. So it's going to give us u plus v times u plus v squared. And this thing is, when you expand it, it's going to give you 2 times u plus v times uv. So plus 2 uv times u plus v, okay, squared. Okay, nice. This is everything in red. Now the additional stuff we already calculated here. They're also going to have u plus v as a common factor, so we can also take u plus v times uv plus 1 squared. Okay, so yeah, that's it. That's the whole numerator. Again, u plus v is going to cancel with the u plus v, so we can actually just write this again in a much cleaner way, and this will be our s. So s is equal to have this fraction that has 2 uv minus 1. Very simple. But now let's just write the numerator. It's going to be let's put everything that has 2 first. Then times u plus v. Oh, sorry, this thing is plus. Okay, let me give some space. Nice. So that's basically our S. Alright, finally. This is like, that was our like nightmare here. And indeed, we're done with that. So we found S. Okay, so now it's time to do the serious work, the final step. That is to check that that thing here is a real number. Okay, so now our goal is to work with this. Let's copy that. Paste it here. And try to evaluate this stuff. First of all, b minus c. So our fraction, let's call it like, what do you want? Let's say maybe capital A. So this capital A is going to be, let's give it a big fraction. Let's find the easy terms first. So b minus c, we already know it's u square minus v squared. A minus t, a is 1. T is what? If you remember, t. Yeah, here is t. T is just minus this. So minus times minus plus. So it's just u square v square. So 1 plus u square v square. Now for j minus h. J minus h. Where is j? Yeah. J is this thing and h is this thing. Okay, this thing is going to be a little ugly. So j minus h is negative and a negative. You can take negative as a common factor. And half as a common factor and multiply this by 2. Let's just try to do some of this here. So j minus h, and then we'll just cut it and put it there. It's going to be minus half, take as a common factor, going to be u plus v minus uv squared 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 plus 1. And that thing we multiplied by 2 plus 2uv plus 2u plus 2v. Okay, let's have a look at this. In fact, you can probably notice that you have u square plus like 2u plus 1. That's u plus 1 all squared, right? In fact, we also have the same thing here. V square plus 2v. You can add a 1 and get v plus 1 all squared and subtract a 1, of course. And then you can actually also notice that you have this and this, because we also have a minus 1. So it's going to be minus, like if you take minus as a common factor, it's uv minus 1 all squared. So this seems a little nice. So basically, like, this thing is just if half times u plus 1 squared plus v plus 1 squared minus uv minus 1 squared. Perhaps you can factorize this. Let's see. If you look at it, you can actually like, you do have a difference between squares, so you can actually apply that here. Let's see. If you subtract these or you add them, yeah, if you add them, you go the 1 will cancel. You're going to have uv plus v. So if you take v as common factor, it's going to become u plus 1. But guess what? You have also u plus 1. So indeed, you can take a common factor here. So you can take u plus 1 as a common factor. And guess what? This is symmetric. So if you have u plus 1 as a common factor, then also v plus 1 can be taken as a common factor. So yeah, this is very nice. So yeah, first of all, let's catch this thing. This was for the calculation of j minus h. J minus h is this. As we said, let's do it step by step. So this thing is just going to be negative half u plus 1. Now you have u plus 1 here, and here the sum gave us u plus 1. Yeah, remember v plus uv. We have actually v, and times the subtraction is going to be v minus uv plus 2. Yeah, that's it. Okay, now of course we can continue. So can take this u plus 1, and we know that we're going to have v plus 1 as a common factor here. So let's just do v plus 1 here, and see what do we need so that we continue. So eventually here we're going to get a v squared, so we need to have a v, and remember, if this thing is symmetric, right? So like this thing here is symmetric as well. Sorry, like I meant that this thing in total is symmetric, so this thing must be symmetric. But because this thing is symmetric, so this thing should be symmetric as well. So if we have a v here, then that means we also have a u here. Now what are we missing? Well, here we're going to have negative uv squared. So how do we get that? We need to have a negative uv. Alright, now of course we have like some number here, plus 1. So to get it from plus 1, we just need to have plus 1. Okay, so that should wrap it. Of course, you can check, apply these, and you're going to get this, like v square and the vu and all of these kinds of stuff. Vu will cancel from here and here, and yeah, everything else is going to give us exactly the same. Alright, very nice. So that means we indeed found that j minus h is really a nice thing. It's in fact just that thing. So let's now go and plug it there. So it's negative half u plus 1 times v plus 1 times u plus v minus uv plus 1. Very nice. And now of course the only remaining thing is the most probably the ugliest thing, which is j minus s, because j minus s has s, and s indeed is ugly. So yeah, now we just need to handle this thing. Our goal is to show a is real, right? In fact, like if we need to show that a is real, then you can ignore the negative half, right? We just need to show that this thing is real. Okay, so yeah, we just need to show that this thing here is real. So that means we just need to equate this with what? With its conjugate, right? In fact, most of these stuff are really nice, because they will basically kind of cancel. Like u plus 1 times v plus 1 is just going to be the same thing as u square minus v square. You just need to probably multiply by uv, numerator and denominator. In fact, all of that will be kind of nice. So all of that is actually nice. The only problem we'll be having is these guys here. So anyway, let's now go and evaluate j minus s. Okay, this is our main challenge. So to find j minus s, j is just, remember, minus uv plus u plus v. This is j, and we have a minus s, so we need to plug it here. So we can actually get rid of the minus, because that just means we need to show this thing is a real number, so its negative is also a real number. So we just need to take this and add s to it. So let's just do that. So let me grab s. Where was s? Here is it, our s. Let's copy that. Alright, we just need to add we need to add basically uv plus u plus v times this. Yeah, so this will be our numerator, this plus this. All of that is divided by 2uv minus 1. And like hopefully this will be factorizable. Otherwise this will be like really ugly, especially when you want to calculate the like conjugate of this. So hopefully this thing should be factorizable. And in fact, like can we really know what are the stuff that going to have like be the factors? If we can know that, if we can factorize it without expanding, life will be much easier for us. Otherwise, like imagine you want like to expand all of that, it's really like going to take some time, although I think it's doable, like you can do it. But like let's see, can we do like some trick here? Can we like really know how can we factorize this? First of all, you need to determine the degree. So here, what's the maximum power here? Let's see, here degree 4. Here we have also degree 4, degree 3. Okay, here probably it's, yeah, degree 5. Yeah, so this thing is degree 5. Let's see here. Yeah, it's less than that. So degree 5 basically. So if you can factorize this, you should know that you need to get degree 5. But do we know, like, can we perhaps know some factors? Well, remember that this thing should be like a real thing, right? Of course, multiplied by all of that. But my main point is that if we take the conjugate, as we said, most of these will, like, these all will cancel with each other. In fact, maybe you just like get some uv somewhere here or here. But this is actually, like, what's the conjugate of this? The conjugate will be, if you multiply this by uv, it's going to be u plus v minus 1 plus uv times, of course, the conjugate of this thing. And of course, as we said, we have like some uv here, some stuff. These are like the same with additional uv. So basically that means this will not cancel with this. So that means that j minus s should have this as a factor, right? So that these guys cancel. So yeah, you can actually catch this as a factor. Like hopefully this thing should be a factor. So maybe you can use this to our advantage. Let me make sure I screw up something here. No, I think, yeah, exactly. This is the conjugate of this after we multiply by uv. So yeah, this thing should have this as a factor. So this thing is degree 2. Remember, this thing is degree 5. So degree 2 is actually good. So let's just, of course, here we're just trying to guess. So probably we have uv plus u plus v minus 1. This is 1 degree 2. Now that means we're just left with a degree 3 here. Can we really guess what are we going to have here? Like, is it like 3 factors, where each one of them linear, or maybe like degree 2 times a linear thing, or whatever? So can we like really get a linear thing here? Let's see. What possibly can we have here? This thing is symmetric, so still this thing is symmetric. So if you get a linear thing with u, then you're also going to get it with v. Then that means we also have here like a third like linear thing that's going to have like u and v, right? So yeah, this is actually a nice thing. This is going to be a function of u, then it's exactly the same as v. Then this should be a symmetric thing that has u and v. But what are the possible stuff that we can have here? Like they're symmetric. Probably like the sum, right? U plus v maybe. This is a possibility. And here like maybe u minus 1 or u plus 1. And like same thing, maybe plus 1 or minus 1. So of course all of this is guessing, but probably like if it's factorizable, then as we said, we should have this. Here I'm just using the ideas of like a polynomial like factorization. It's really important to keep that in mind. So let's actually see. We can, without expanding, we can know whether, for example, u plus v is a factor or not. Let's see. If u plus v is a factor, then this thing is 0. This thing is 0. Okay, all of this is cancelled. This thing here cancelled. Let's see. We're going to get 2 uv minus 1 plus, okay, if u plus v is 0, then actually if u plus v is 0, then u square plus v square is equal to negative 2uv, right? Because like just move that there. So we can replace this thing with negative uv. So negative 2uv 4v squared plus this thing here 2uv, let's take it as a common factor. It's going to be uv plus 1. Let's see, do they cancel? 2uv squared 2u square v square. Okay, nice, nice. Minus 2uv plus 2uv. Okay, okay, exactly. So indeed this is indeed like a factor. Very nice. So that means now we got u plus v also as a factor. Now we either actually have this thing is factorizable, or maybe it's just degree 2. It's like not factorizable. Let's try to search for a linear thing. Like if we have a linear thing, then what possibly can we have? Maybe like u minus 1 or u plus 1. And same thing here, like minus 1 or plus 1, right? But because here everything is plus plus plus, most of the stuff are plus, the only minus is here, so probably it's not u minus 1, probably it's u plus 1, right? So let's try u plus 1. Let's see if it works. So if u plus 1 works, then that means u equals negative 1 is a root. So let's just try plugging u as negative 1 and see what will cancel. If everything cancelled, then we're good actually. In fact, like if everything cancelled, then we immediately don't need to expand all of that, right? We can immediately write this as the factorization, and of course we can double check quickly. So anyway, let's just try to see whether u plus 1 is a factor or not. So let's just plug u as negative 1 and see what will cancel, what will happen. Let's evaluate it. 2v squared minus 2v minus 2v times 1 plus v squared plus v minus 1 v squared minus 1 plus v minus 1 v squared plus 1 plus 2. Okay, this thing negative v plus v. Okay, so this is u. Sorry, yeah, it's uv will cancel the v, and u itself is negative 1, so it's negative actually. Negative 2 times, and this thing here is negative v negative 1, so it's plus 2v plus 1. Let's see, does this cancel? Let's see. Okay, 2v will cancel with 2v. Nice. What else will cancel? Let's see. 2v squared, will it cancel? We're going to have v minus v squared from here. You know what? Let's just evaluate it. Let's expand. This should be not difficult. Let me use do again. 2v squared minus 2v minus 2v minus 2v cube plus v cube minus v squared minus v plus 1 plus v cube plus v minus v squared minus 1 plus 2v plus 2. Let's see. Now, will it cancel or not? Okay. We have minus v squared, 2v squared cancelled. And we originally have 2v cancelled with 2v. Nice. What else? We have a minus v. We have a plus v. We have a v cube, and minus 2v cube. We have a 1 with a minus 1. What else? It seems that it's not Here we have a plus 2, and here we have a minus 2v. Did we screw up somewhere, or it's just like not factorizable? Let's see. Okay, is this correct, or we screwed up somewhere? This thing is correct, this is correct, minus 2v correct, v squared plus 1 correct, v minus 1 correct, v squared, yeah, here it should be plus, not minus. Do we have any mistake, other mistake? V minus 1 correct, v squared plus 1 correct, plus 2. Yeah, this thing we checked it twice, so yeah, it works. Yeah, so right now what is the mistake now here? What gets affected? Here, when we got v cube and plus v, where did we get it? Okay, v cube. Now instead of the minus, the plus 1, should have a minus 1 here, and also should have minus v square is still the same. Yeah, this thing is plus v now. Yeah, now we'll just let's double check everything. Okay, let me cancel everything again. Okay, it's good that we caught the mistake. Let's see. Again, 2v squared minus v squared with a minus v squared. Nice. What else? Minus 2v with the plus 2v. Minus 1 plus 2. Now it cancelled. A v cube and minus 2v cube, it cancelled. A v and minus 2v. Does that cancel everything? Yep, it cancels everything. Very nice, very nice. So that means we have indeed, we've shown that u plus 1 is a factor. And of course, by symmetry, we should have v plus 1 as a factor. And guess what? Now we just got like the degree 5 that we want. So in fact, this thing here should be, the numerator should be exactly this. Should be exactly this. Because it's degree 5, and we showed that it has this as a factor, this as a factor, this as a factor, and this. Actually, we don't know that this thing is is a factor. It should be a factor for us to solve the question. But right now, we only proved that these 3 are factors, right? So now, actually, what we can do simply is just check that this is indeed what we need to get this thing. So yeah, we just need to make sure if we expand this, we get this thing here, the numerator of it. Just yeah, probably the best way is just to expand this and this as well, and check that they are equal, because I don't see a method to immediately see this thing is a factor. But if you know an idea, then let me know in the comments. But yeah, probably this thing is really easy. You might tell me, okay, we could have immediately from here just expanded everything. Why did we have to go all through this suffering, checking if this is a factor or not, and these guys? Well, the reason is simple. Here, even if you expand it, what will you do then? It will not be easy to factorize. It will be degree 5, right? You cannot factorize it easily. But here what we did, we thought about this. If this thing should be factorized, it should have this as a factor for us to have this thing is real. This to cancel. So from here we said that this should be a factor. This thing is degree 2. If this thing is degree 2, this thing now is degree 3. It's either a whole block of degree 3, probably not. We can factorize. If this can be factorized, if we have a single factor, one of them will be linear, the other is quadratic. But if we have a linear that has u in it, only u, then we should have only v here, and that means we should have actually 3 linear factors. Otherwise, we have only a linear symmetric factor that has u and v, and the other is just a quadratic thing. Anyway, we check that u plus v works. For u plus u, if we only have a u here, like probably u minus 1, u plus 1, these ones should be like, you should think about them, but we saw that we don't have negatives here, so probably it's a plus. So yeah, we checked that u plus 1 works, so that means v plus 1 must work. And indeed, now like it's very easy to expand this. It will take like maybe like not more than 1 minute. And this thing as well, yeah, this one might take like maybe 2 minutes, 3 minutes. But once you do that, you can easily check that these two are equal. And hence now we're nearly done. Our question is nearly solved. This problem 3. So because now we can just go there and plug everything, right? So now this thing is equal to the numerator. Denominator is still this. So we can just like go and plug that there. And here the j minus s. Anyway, I'm going just to copy this. By the way, this is not a because we had a negative half, but who cares? We just need to show that this thing is real. Of course, if you are in a contest, then don't write a. Should write that you divided by negative half. Anyway, I'm just going now to replace j minus s by that thing. U plus 1, v plus 1, and this that thing there. So instead of j minus s, going to multiply this by this fraction. Here we have the 2 uv minus 1. By the way, we don't care about the 2 again for the same reason. So just uv minus 1, and the numerator is just all of that thing. We just copy it actually. Okay, now we just need to check that this thing is a real number. Now in fact it's a piece of cake. It's really easy. First of all, of course, these are repeating. So just use square, and probably let's just put u plus v there, and we can actually put uv minus 1 here. Yeah, just like we need to multiply by this as well. We just need to check that this thing is real. Okay, so let's find the conjugate of this. The conjugate, of course, first of all you have u plus 1, so it's going to still be u plus 1 squared, and v plus 1 still squared, but you need to multiply by u squared v squared in the numerator. Same thing in the denominator. Now you have like I multiplied by u squared v squared, then you also multiply it here. So now you have u squared v squared, but this will be consumed here, and in fact it's just going to give us exactly u minus v squared, but with a negative. So now we have a negative here. Okay, first part is nice. Next, this thing here. This thing needs a u squared v squared as well. It will give us exactly the same thing, but we need now to multiply by u squared v squared above. Let's see. U square v square above. Let's take a uv here. This will consume a uv. Still will give us u plus v. We have another uv. Let's put it here. So this uv is going to give us u plus v minus uv. Sorry, minus 1 plus uv. Okay, now everything is consumed. Again, we need another uv and multiply it by the denominator. It's going to give us 1 minus uv. So now we have uv minus 1, and this negative is gone. Now we also multiply by uv there, and we get 1 plus u plus v minus uv. Okay, let's see, are these the same? This is the same, this is the same, this is the same, same. U plus v plus uv minus 1, uv plus u plus v minus 1, u plus v minus uv, u plus v minus uv plus 1 plus 1. We're done. Finally, so this thing is indeed real, and hence the arc of the two angles, the angle, like the arc of the first number, the same as the arc of the second number. That means indeed these two angles are equal. And finally, we're done. That's it. So as you can see, that was like problem 3, but like we solved it using absolutely no geometry. knowledge here, just some algebra, right? So it's like for sure worth it. As a summary, complex bash is really a powerful technique, and like not as some people think that right now like we cannot have a question that can be bashable with complex bash. No, it's still we can see many questions like are bashable, but of course they are not that easy to bash. So as you can see here, this was not a standard bashing. Like we need to do some nice tricks, right? For example, it's not a direct thing to find q. We needed to define this q prime and p prime in order to find these. And then even if you do that, like S will be really ugly. So if we don't follow really this technique of like finding these tricks here and there and factorizing these polynomials, really it will take too much time. Maybe like it will not fit during the test time. So yeah, although you might lose your hands while solving the question, it's really worth it. So basically a quick recap for the question. First of all, we just use the standard thing of giving coordinates u square, v square, w square. We gave a 1 in order to find q prime, p prime as I and negative I, so that we can find p and q. H and I are easy to find, we already have them, but S is the intersection of these two. To find the intersection of two chords, we can use the two chords intersection on the unit circle, of course, formula. In order to do that, we find PQ and then P plus Q. Find them, each one of them separately, so that you don't mess up. And then, like the key in doing a complex bash is to make sure you don't mess up. One small mistake and you screwed up. Like you will get literally 0, no points at all. This is very like harsh, but it's logical because you're not really doing some geometry, so they cannot like give you really points here and there on your claims, because you don't really have claims. You're just like computing everything and just going on. So you really need to be careful not to mess up. At the same time, it's really a powerful technique because you're literally not doing any geometry right now here. Of course, you need some like geometry observations at the beginning, but once you're inside the calculations, you need to be just an expert in algebra actually to make sure to do the factorization that we did, and be like able to simplify stuff. Don't expand everything. Make sure you don't do unnecessary calculations. So as you can see, after we did that, we easily found S. We noticed that the denominator was really simple. It's just like 2uv minus 1 times u plus v. So we expected the numerator to be divisible by u plus v. Indeed, we checked that using our like polynomial, let's say, factorization techniques, and we just took u plus v, cancelled that. We found S. It was like kind of ugly, but then we just needed to consider this quantity. We found everything except j minus s at the beginning, and like the challenging one was j minus h, but we easily factorized that. Then we just wrote this thing and worked for j minus s. We evaluated j minus s. It was this thing here, and we thought about it, that it should be factorizable. We cannot really just have all of that because at the end of the day, we want this to cancel with this, right? So it should have this, like this thing should have this as a factor. Indeed, we just try to do that. We did that here. Then we thought, what should we have here as well? We knew this thing is degree 3, so we said if this thing will have only u, then this thing will have a v, and that means this thing should be symmetric. It has u and v. Or you might just have like a u and v, and like here just a quadratic thing. But we just tried, if we have just a single u, then you either have +1, -1. This thing is the standard thing, really. So we just tried that, and eventually like everything indeed simplified. So indeed this thing was just that, and then yeah, from there everything followed, everything cancelled, and basically we were done. So yeah, that was like our problem 3. Again, like we really didn't really like use the geometry here, but this is like the idea of the complex bash, right? You're escaping the synthetic solution using these like instead algebra calculations. So I really stress that you should be mastering these bashing techniques. They are going to help you a lot in your math Olympiad journey. So make sure that you don't ignore them, unless you're really like very powerful in the synthetic geometry. I know like many people really hate on these bashing like solutions, but I figured out to do such like a one, because on my channel so far we didn't do any. So we needed to stress the importance of a complex bash like through this question. Of course, we'll be discussing this on our EGMO playlist soon on chapter 6. Okay, so I hope you guys enjoyed this video and didn't like suffer with me. At least your hands should be okay. Okay, so make sure to share the video and like subscribe to the channel, and see you guys in day 2.